Okay, so let's look at some of the properties. Let's look at commutative property. So in commutative property, what we are saying is that something is looking at it this way and switching it around is the same, right? So you see a commutator switch, if you have a machine, is something that will keep switching from one side to the other. You switch this side and switch that side. This switch this side. It keeps changing. It comes from the word commute. Commute means you are in place A, you have to go to place B. You are from here, you have to go there, you have to come back. This is called commute. Going back and forth. That's called commute. So if you are going one way and then you are going the other way, it's called a commutative property. 2 times 3 is 3 times 2. Going this way or going that way is the same. Now, this is of course fairly straightforward. This is what we do all the time. So it is a matter of perspective. Perspective means how we look at things. Yeah. So are we looking at these 2 times 3, or are we looking at it as 3 times 2? But the area is the same, you see. It's a rectangle. A rectangle has an area. So the question only is, the area of the rectangle, are you looking at it as length times breadth, or you're putting at it like this, and then this becomes length times breadth. But the same length, the same breadth. You're just rotating the rectangle. The area doesn't change. Right? So if this you are going to call first, whatever is this side, you're going to say B times L. This is L times B, and they are the same. The area is the same. So that's the idea of commutation, that the area stays the same. So next we can look at associative property. Again, what does the word associate mean? Associate means related to. The two things are related. So if I have, let's say, 2 times 3 times 5, they're saying we can associate these two first and then we can multiply it by 5, or we can do this as well. Okay, so whether we do it like this or we do it like this, multiplication has an associative property, and so does addition actually. But okay, so if you look at multiplication as associative property, then just like we looked at commutative property is a matter of perspective and is related to area, associative property is a matter of volume. That's all. So let's take this. This is 3 times 10, 30. I am taking the rod. So these are just 3 times 10. So now let's give it some height. Right? So let's give it one layer. That's another 30. That became 60. Right? Let's give it another layer. Another 30. It became 90. Let's take 3 more. Another 30. That became 120. So this becomes a volume. You see? So we started with 3 here, 10 there, 4 height. This is 120. But no matter how you hold it, if you hold it like this, it is 3 here and 4 there and then a 10. Height is 10. 3 times 4, height is 10. Right? So, or if you hold it like this, it is 4 times 3, height is 10. So it doesn't matter how you go about multiplying the volume. There are 3 items. It doesn't matter if you multiply 3 times 10 first and then you multiply by so whether I do 3 times 10 get 30 and then multiply it by the height 4, or I flip it around and I do 10 times 4 first. I can even keep it like this. So 10 is first, 4 is second, and then I multiply it by 3, I will get the same volume. So that's what associative property means. Otherwise, to get the volume of an object, if associative property was not true, to get the volume of an object, I need to only measure it in one way. And if I don't measure it in that way, I won't get the volume. How foolish is that? I should be able to get the same volume no matter how I build it. So this is what associative property gives us, the ability to calculate volume in any way. So distributive property. Now what is the word distributive? It comes from the word distribute. What does distribute means? Giving it away to different people. Right? So there are 2 groups, I can give something away across 2 people. So this thing looks like multiplication is distributive over is distributive over addition. Okay, so what that means is, if I have 2, so my height is 2, right? Height is 2, and I can put 5 blocks. This is 2, and then I can put 3. Okay, so it means I can add the area of 2 times 5 with 2 times 3, or I can consider this as 8 first and then multiply by 2. I will get the same area. This is the most powerful property among all the properties, because without it you cannot do 2-digit multiplication. You will go mad. Okay, it is because of this that you can do your 2 times 32 as 10, 10, 10. Well, my 10s are not the same length, they should be, but there's no space, and 2. Right. So I can do something like this. Sorry, there, on this one, and then 2. Otherwise, I will not be able to do it. So when I am saying, okay, I am multiplying 32 with 2, I am imagining that I should be able to multiply 2 times 2 and get a 4. I should be able to multiply 2 times 3 and get a 60, and I should be able to add the 2. Now, if I could not do this, my multiplication will be horrible. I have to divide all the numbers into separate numbers, multiply them separately, add them all together, and all these things, that all the shortcuts that we have would not work. So the distributive property is extremely useful in order for us to do simplified calculations. All these properties can help to make calculations much simpler if we are able to see patterns that make multiplications easy, right? So if I have even something as simple as that, if I can identify the pattern that 2 times 5 will give me a 10, then I can say it's 30. So I can identify patterns that make my life easy, then I can use these properties that we have looked at to do our work.